All right, let's look at an example combines all the transformation techniques together. Okay, so we want to graph the function f of x equals 2 over x plus 2 minus 1. And we also want to find the domain and the range of this function. So first step, we need to identify what will be the key function we can use, okay, to start the process. If you notice, this function have the variable, independent variable x on denominator. So in the key function in our library, the only one has variable on denominator is the reciprocal function, right? So first we identify reciprocal function, and then we know the graph is like this shape. And then second step, we want to get graph for 2 over x, which is like a 2 multiplied by 1 over x, right? 1 over x is the reciprocal function. So outside of reciprocal function multiplied by 2, that's outside function, that's a vertical direction, right? Multiply, divide is either stretch or compress. So vertical direction multiplied by 2. 2 is a number greater than 1, so it's vertically stretched by 2. Okay, vertically stretched by 2, that means for every x, okay, same x coordinates, y coordinates doubles. Okay, so my graph is not accurate, okay, for the stretch, compress. I just show you the meaning, okay, it's vertically stretched by 2. And then the third one, we want to graph 2 over x plus 2. Okay, compare with the previous step, 2 over x. Now I replace x by x plus 2, right? Replace x by x plus 2. So that's obviously it's an x change, right? X change, that's a horizontal direction. Plus minus is a shift. So it's a horizontally shift. Shift where? Left or right? We need to rewrite x minus negative 2, right? X plus 2 is equivalent to x minus negative 2. So horizontally shifting to the left-hand side, 2 units. Okay, so now the graph horizontally shifting to the left-hand side, 2 units. So y-axis should move here. Okay, graph is like that. And then the last step, finally, outside function, minus 1. Right, this is the previous graph we already got from step 3, right? Outside function minus 1. Outside function does vertical direction. Plus minus is a shift, so vertically shifting down 1 units. Okay, and then x-axis need to go down and then vertically shifting down. My hand graph is not accurate. Okay, so now let's look at an accurate graph. First step, reciprocal function. Okay, that's the reciprocal function's graph, and then vertically stretched by 2. Okay, this is vertically stretched by 2. Start from here, and then horizontally shifting to the left-hand side, 2 units. Okay, that's the new graph. And then next step is from the graph we got from third step, and then vertically shifting down 1 units. Okay, that's the final graph. So what will be the domain and range? So now remember, this is the y-axis, okay, original y-axis. This is original x-axis. That's moved to here, right? This line is x equals negative 2. This line is y equals negative 1. So what is the domain? Domain before for original reciprocal function is x cannot equal to 0, right? So now is x cannot equals what? X cannot equals negative 2, right? And then what about the range? Range is the same, right? Range, let's see, y cannot equals what? X cannot equals negative 2. y cannot equals -1, right? Y cannot equals -1. Because this will never touch the x-axis. All right, and then last example. Sorry, this is a missing. So we're trying to get a graph for f of x equals square root of 1 minus x and outside plus 2. Okay, and then 4 steps transformation. And then it starts from square root function. Okay, because here we have a square root, right? So that's why the key function from our library is square root function. And then first step is replace x by -x. Okay, here we have a -x, right? Replace x by -x. So that's reflection about y-axis, right? Reflection about the y. So the graph become here. Okay, it's right here. This is a new graph. That's a reflection about the y-axis. And the next step, so inside the reciprocal function, right? We have -x plus 1, but actually negative sign is already applied to the x, right? So we need to rewrite into the parentheses as x minus 1. Okay, if open parentheses distributive, that's -x plus 1, right? So actually it's a negative of x minus 1 in the parentheses, so we need to replace x by x minus 1. So another horizontal. Plus minus is a shift, right? So replace x by x minus 1 is horizontally shifting to the right-hand side 1 units. That's the graph. And then finally, outside the function plus 2, that's a vertically shifting up 2 units. That's how we got the final graph. Okay, transformation is always do step by step. So the key is, multiply, divide first. So we will do stretch, compress first, and then reflection is also multiply. So and then do reflection, and then do the adding, subtracting, which is a shift. Okay, that's the preferred order. This is section 3.5.